Now we're going to talk about specifically what is CI and what is CD, because they are two separate things, even if they're done kind of at the same time in the same program. I'm going to say program for now. Continuous integration. Continuous integration is all about taking our new code changes and making sure they can safely be integrated into the existing code base. So like I said in the previous video, we have a repository, and in our repository, we have our main branch. Let's say for a second a software developer is down here and they've cloned the main branch onto their laptop, and they're tasked with fixing a bug. I'm going to put BF right here for bug fix. So if this is the main branch and they've got a copy of it on their computer, and it looks like this on their local computer, again, remember, this isn't touching the main source control repository right now. This is all on their local computer. What they're going to do is they're going to say, okay, what I'm going to do is right here on this commit, I'm going to split off onto the side and make all of my changes in a totally new branch. So we call this right here, where we are, the head. So instead of making new commits on the main branch, my next commit is going to happen down here. And all of my changes are going to happen in parallel to the main branch on what we're going to call the bug fix branch, like this. So let's say we make it all the way down to this point and our bug is now fixed. What has to happen now is we have to get all of these changes merged back into the main branch. This could be a lot of code. This could be a lot of changes. And these changes could disrupt how the main branch, or really how the production environment, is currently working. So what we have to do is we have to integrate our code into this main branch, basically taking all of these changes, packaging them up, and now putting them on the main branch like so. This is a risky operation because, the main branch could rely on certain versions of software, like it could rely on Python version 3.11. But if I'm building this on my local laptop and I have Python version 3.14, does that break anything? We don't know. We don't know until we go to integrate these code changes into the environment. I may have installed a package in Python that helps me do math, makes math simpler. Writing code to do math might make it simpler. Is that package currently installed in the main environment? We don't know. These are all integration risks. I could change a line of code accidentally or on purpose that breaks our ability to sell products. Now, I may be thinking like my bug fix was, the text was red and that made it overlap with the header. So I've now fixed that, but I didn't go through and test if I could still buy products. These are all the integration risks that come into play. So what we can do is we can actually build a pipeline. This is called the CI/CD pipeline. And what we can do is when I go to perform or request, when I go to request that my code, my new branch, gets merged into the main branch, we can automatically run a series of tests that make sure we can safely integrate our code changes into the main environment. This happens automatically. The moment I say, okay, I'm ready to merge, I click the button, this triggers a series of automatic tests to take place to make sure our code can safely be merged into the main branch. Now, this could be compiling code. Can we still compile an EXE or a DLL? This could be just making sure that there aren't any dependency conflicts. This will make sure there aren't environment conflicts, that pieces of the environment aren't missing or overwritten. So it's really all about combining our code together and making sure my versions and my environment matches up, or we didn't change anything from what the main branch expects. So once CI is done, you can expect this commit to now be the next commit on the main branch. CI has said we can safely integrate these code changes into the main code changes without breaking the software environment. So now we have a new commit sitting in source control. What has to happen next? We have to get that commit onto servers, maybe for testing or maybe for production. That's what continuous delivery is all about. Sometimes it's called continuous delivery. Sometimes it's called continuous deployment. For now, you can think about those as synonyms or equals to each other. They're the same thing effectively. So what this piece does is now automatically, that's the key word here, automatically it will detect a new merge has happened, a new version of the code is available, and it will go to the production servers, and clone the new software onto these servers. Excuse me, I said production servers. It will go to whatever target servers you say. This could be a dev environment, a test environment, or the production environment, or staging environment. Could be any of those. But what it will do is it will say, okay, I now see there is a new version of the code available for me. It is time to clone all of that code onto these servers, restart the services, and get them up and running. So it will automatically deliver the code into your environment. But wait, there's more. What happens next when code is delivered to an environment? What typically happens next in your environment? Typically what happens next is testing. Does it work? We need to check it out. We need to go and see if this code is working. Well, we can actually have CD automatically perform tests for us. Now, there's 4 or 5 different kinds of testing methodologies that happen in this environment, and we can automate a lot of these to make sure that once this code is delivered, the application still works the way we expect it to. So if you think about this in the grand scheme of things, our developer clones the code, makes some changes on their own, and then submits a request to get the code put back into the main branch. This triggers the CI/CD pipeline, where it validates that this code is safe to merge into the main branch, and once it is, that triggers automatically the CD pipeline, which will then get that code running in production or test or staging or whatever. It will be completely, this new version of the code will be automatically shipped, deployed, and running on the target servers, and then automatically run a series of tests to make sure it runs correctly. Let me show you a real-world example of this. If I flip back here and go here, this is what a CI/CD pipeline looks like. I'm on GitHub. This is a code repository. I'm currently on the main branch. Here's the code itself. With GitHub, we can define a CI/CD pipeline with a single YAML file. When we create a folder called, this is just for example, by the way, you don't have to know this for the test, but this is just to show you what it looks like in the real world. When we create a folder here called .github, inside of that, GitHub automatically looks for workflows. And inside that workflow, we have a YAML file. So we say when there is a request, a pull request, that's where we're asking it to be merged, then start up some servers. Then build the software. This happens automatically. And you can even see right here things like check for buttons. There's your test right there. Do we still have buttons in our software? Because if we deleted our buttons, sure, it might be able to compile the code just fine, but it won't work because we lost our buttons. We can create software that does our tests for us, And if we get a good result back from this, we know it's safe to deploy this code. Who uses this today? Let me ask you this. When was the last time you saw Amazon.com go down? For maintenance, for bug fixes, or for new features? I mean, Amazon.com changes pretty frequently. They ship new features all the time. I mean, the first purchase I ever made on Amazon was in 2005. I bought a CD. And in that time, I don't remember Amazon ever going down. But they ship new features, new capabilities to Amazon probably every day. I don't know. I don't have internal insight into it. But they've got a pretty big team of software developers at Amazon. So you got to believe, or I mean, I know for a fact, they have a very robust DevOps lifecycle. This is a software company at the end of the day. They make a web application that sells stuff or enables other sellers to sell their stuff. So they are creating new software every day. They are requesting their changes to be merged into some branch every day. That is triggering integration tests to make sure it is safe to merge every day. When that happens, it triggers a deployment service to ship those services into some server every day where tests are run to confirm that it's running accurately every day. We can even automate things like if you deliver all the way to a test environment and run the test and the tests all look good, automatically ship that into the production environment. This is where CI/CD comes in. So think about the journey now. You've got the whole DevOps lifecycle, build, plan, then integrate. This is integrate. And at the heart of it all sits source control. Nothing happens without source control. So now you're kind of seeing where we're going with this. You might be thinking, well, where do network engineers fit in? The cool thing about this is when we say, we got a new version of the software coming out and we need new servers with this particular subnet up and running, we can build that into this pipeline so that then we can deploy new virtual machines and new networks to support it automatically. And we could run tests against the network to make sure, is OSPF running with this new stuff? We can get all of that going automatically. And once the network is up and the VMs are up, then deliver the code into that. That is what infrastructure as code is. Infrastructure as code is part of a CI/CD pipeline, which is part of the DevOps lifecycle.